All right, system of inequalities. We've done systems before. This time we're just going to be doing all of the inequality notation. So the first thing I want you to know is that if we have a less than or a greater than symbol, it means it's a dashed line. And if it's less than or equal to or greater than or equal to, we have a solid line. Anytime we have less thans, we're going to shade below. And anytime we have a greater than, we shade above. Okay, so commit that to memory. That's something from Algebra 1 that you have heard before. Please write that down somewhere in your notes. Next thing is we're actually going to graph this. So you can grab 3 different colors, pause it, do whatever, and let's go and get started. So the first color, I'm going to graph everything bigger than 0. So that one's easy. Starts right here. Boom, boom. And I'm going to graph everything bigger than 0. So since it's left to right, we don't really have up or down, but it's going to go to the right because it's everything greater than 0, right? Positive numbers are bigger than 0. For my other two, I got to solve for y. So my first one, let's solve for y. Move x over. I got negative x plus 15. And I need y all alone, so I'm going to divide each piece by 3. So I got y is less than or equal to negative 1/3 x plus 5. So that means my y-intercept is 5. Go down 1 over 3. Down 1 over 3. And keep going, blah, blah, blah. And then you have to ask yourself, is this a solid or a dashed line? It is a solid because of the or equal to right here. Last thing is, do we shade below or above? Shade below because it's less than. Third equation, do the last color here, x minus 2y. I need to move x over, so I get negative 2y is less than or equal to negative x. Then I'm going to divide both sides by negative 2. When I do that, I flip the sign, so y is greater than now, or equal to 1/2 x. So I start at 0, go up 1 over 2, up 1 over 2, up 1 over 2. Solid line, because it's or equal to again. And then I'm shading above. So that means my intersections are here, here, and here. And so all my answers are within here. That's what we're doing. We just find every x comma y, every coordinate that falls within this triangle is a solution to all 3 of these. So we got A. B wants to know, are the vertices solutions? Well, since all 3 lines are solid, that means that all vertices are solutions. If they happen to be like dashed lines or something like that, then it would depend. So like if this green line was actually a dashed line, then the only one that would be a solution is this one, because this part has a dashed line and this part has a dashed line. So yeah, that's the first example. Number 2 works the exact same way. The only difference is that this line is dashed. So once you graph it, you're going to get in the triangle, and then B, the only one that's going to be a solution is the one that doesn't have any dashed line. So I'll let you do that at home. The last couple are word problems, so I want to be sure we go over those. I'll let you read that there. For number 3, it says that juniors and seniors must be between 5 and 8. So J plus 8 is going to be no more than 8, right? So less than or equal to 8, and then also has to be more than or equal to 5.
Got the football, that's good.
All right, sorry about that. Anyway, so we got J plus S is less than or equal to 8, and then J plus S is greater than or equal to 5, because we need somewhere between 5 and 8, and we can have 5 to 8. The next part, it says that J has to be at least 2, so J greater than or equal to 2, and S greater than or equal to 2. And that's it, because we want at least 2 and at least 2 there. My next one says we got to work 20 hours. So our dog walking job plus our car washing job needs to be at most 20 hours. So that's going to be less than or equal to. Then for our cash one, the 92 and 750 and all that stuff, our dog walking pays 750, so I'm going to do 7.5D plus 6C. We need to at least earn 92 bucks, so greater than or equal to 92. So that's just reading it. Sometimes we need 4, sometimes we need 2 equations, sometimes even 3. Number 5, the last one, a word problem with some graphing. So first writing the equation. So I want x to be adults and y to be children. So 10x plus 5y, we want to sell more than $600. So actually it's not greater than or equal to, it's just more than, so just greater than. And then my other one, we at most can have 100 people in our seats. Okay, solve for y on both of those, and then we're going to graph them. My second equation is easier to graph first. That's y is less than or equal to negative x plus 100. And then my other equation, move x over. I get negative 10x plus 600. Divide both sides by 5. And y is greater than negative 2x plus 120. So we graph both of those. Let's see if I got a finished product here. Yeah. We graphed both of those, labeled my axes, did all that stuff. Then C wants to know if 42 comma 29, if that point right there is in my solution. Obviously it's not. That's all this area right here. So the answer is no. Then lastly, or not lastly, but next, wants to know if there are no adults in the performance, so only kids, so 0 adults. Is this point in my little black triangle? No. And then lastly, if I sold 100 adults, so 100 adults would be out here, 100 adults. I think this graph is off now. Somehow this graph got off. But anyway, 100 adults would be out here. That's actually in my triangle. So that would be $1,000 profit with 100 adults and 0 kids. Hope that helped. Come on in for tutoring if you need so. See you later.